Hi everyone, my name is Eva Ruiz. I have a Bachelor's of Science in Computer Science and a minor in Mathematics. In this activity, we're going to learn how to code with a deck of cards, which is also going to teach us how to think like a programmer. So let's get started. Here's the list of materials that we're going to need. So we're going to need a clean surface, a deck of cards, some tape to secure the cards onto the surface, some toys or any small household item that you can find, and that's it. So let's go on to step one. Lay your cards out in a 7x7 grid and secure your cards with some tape so that they don't move around. So your cards should look like the picture that is on this slide. Step 2 is to choose a toy or any small household item that you can find that can serve as your computer and place it on the bottom left card, as this is going to be your starting position. And in this example, we're going to be using an elephant as our computer. Step 3 is to choose a toy, a snack, or any small household item that you can find that can serve as your prize and place it on the top right card, as this is going to be your destination. And in this example, we're going to be using a Kit Kat bar as our destination. And so now our cards should look as so. Our elephant, which is our computer, is on the bottom left card, and our Kit Kat bar, which is our destination, is on the top right card. Step 4 is to add some toys or any small household items that you can find to act as obstacles. And here we can see the obstacles that we're going to use in this particular example. Step 5, let's begin. You are the programmer in this activity and must give the computer directions on how to get to the destination. So let's start. Here we have our elephant, and there's two different paths that our elephant can take. So in this example, we're going to go ahead and tell our elephant to move 3 steps forward. So here we have our elephant that has moved 3 steps forward. However, it has reached an obstacle. So what's the next step? Yes, we have to tell our elephant to rotate 90 degrees left, and here we see a clear path ahead again. So we can go ahead and tell our elephant to move 2 steps forward. However, we come across another obstacle, and this time it's a chicken. So what do we have to instruct our elephant to do? We're going to tell our elephant to rotate 90 degrees right, because there's another clear path ahead again. And we can go ahead and tell our elephant to move 1 step forward. However, we come across another obstacle. So what do we have to instruct our elephant to do? Yes, we have to tell our elephant, rotate 90 degrees left so we can have a clear path ahead again. And so now we can tell our elephant to move 4 steps forward. However, we come across another obstacle. This time we're at the edge of the cards, and so we're going to have to tell our elephant to rotate 90 degrees right. And now we have a clear path for the destination. And so we can go ahead and tell our elephant to move 2 steps forward. And now we can tell our elephant to stop, because we've made it. We finally made it to our destination, and we finally made it to our Kit Kat bar. And guess what? We just wrote an algorithm. So what is an algorithm? An algorithm is a set of instructions given to a computer to perform a certain task or set of tasks. And that's exactly what we did. Our elephant was our computer, and we were instructing our computer, or our elephant, to go through a certain path to reach our destination. And we were being very specific and detail oriented, because remember, we were telling our elephant to rotate a certain amount of degrees in order to have a clear path again. So we were thinking like a programmer, because we were giving very specific instructions. And another cool thing to note is that an algorithm can be turned into code just by using a programming language. Pretty cool, right? So the algorithm that we just wrote can actually be implemented into code. Here we have the algorithm that we just went through in this example. But remember, there are always multiple solutions. So this is actually not the only algorithm we could have implemented. Remember that our elephant at some points had different paths that it could have taken. So there are multiple solutions. And this is always the case whenever you start coding and programming. So can you figure out another solution to this example? I think you can. So try it again and make it more challenging by adding more obstacles, writing out the entire algorithm beforehand, not as you go, and maybe add in some rules. So for example, maybe you're not allowed to rotate a certain direction. And always try to find the route with the least amount of steps, because as a programmer, you always want to implement the most efficient solution, because in the long run, this is going to save you the most money, time, memory, and resources. So can you go back and try to find the route with the least amount of steps? We have now concluded this activity, but I hope you can try it at home with your own deck of cards, with your own items, and even try it out with a friend. And if you want to code some more, visit scratch.mit.edu. And if you want to do some more unplugged activities, then go to teachyourkidscode.com. Thank you so much for watching and happy learning.